Welcome back to day 2 of section 2.6, where we have been talking about the quadratic formula. Yesterday we learned how to find the solutions to a quadratic equation by using this thing called the quadratic formula. Today we are going to focus on a subset of the quadratic formula to help us decide how many solutions we're going to have even before we begin. Before we get started, let's practice what we did yesterday. As a warm-up, first I want you to try to graph the function 2x squared minus 7x plus 3 in your calculator and find the solutions. Remember, when you graph to find the solutions, you are figuring out where it crosses the x-axis or finding the zeros of the graph. I also want you to try using the quadratic formula like we did yesterday. So go ahead and pause the video and again take your calculator out, try to graph 2x squared minus 7x plus 3 and see if you can find your zeros. And then also solve this using the quadratic formula. Okay, here we go. Hopefully you found 2 different solutions. You can see a picture of my calculator screen. When I went in and graphed it, I went to the Y1 menu and I typed this in. Then I had to go to second calculate and pick the zeros. I took a picture of the 0 and it told me that the first one was at 0.5. Then I repeated the process for this other one and found that it was at x equals 3. Okay, now on the right hand side here, you can see that I used the quadratic formula. As a reminder, the quadratic formula is x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So hopefully you're able to identify your a, b, and c and then do the math correctly. This was another situation where there was a perfect square. I got the square root of 25, so 5. I added 5 to 7, got 12 over 4, which is 3. Then I subtracted 5 from 7 and got 2 over 4, which is 1/2. Now, here's the key. We got 2 solutions both times, and again, notice they're the exact same. So yesterday we did an example where we did it with the quadratic formula and factoring, and we saw that both worked and we got the same thing. This one shows that we could also use solving graphically to get the same 2 things. If I factored this one and solved that way, I would also get 3 and 1/2. Okay. So now that we reviewed this, today we're going to focus on this idea of how many solutions we get. And in this case, we get 2 solutions. But now let's think about why that happened. Remember this symbol plus or minus? As soon as we get a number over here, we break it apart as 7 plus that number and 7 minus that number. That means that it is this radical part that determines what we get for answers. This part right here. That part under the radical, this b squared minus 4ac, is a very special part of the quadratic formula that we're going to talk about today. Okay, so let's look at this picture now. Okay, so the first one is the one we just did. Okay, when we graphed it, we had these 2 x-intercepts. When we did the quadratic formula, we got 2 answers. Okay, so they forgot that and came out as 2 nice numbers. Okay, now 4x squared plus 12x plus 9, you can see that when they graphed that, the vertex was right on the x-axis, which means that there's only one solution. When they did their math, because they got the square root of 0 using the quadratic formula, whether I add or subtract 0, it just gives me one solution. And finally, in this case, this third one, it never crosses the x-axis, which means there's no real solutions. Well, when that happened, we can see that our final answer had an I in it. So even though it doesn't have a real solution, it does have these things called imaginary solutions or non-real solutions. Now that happened when we had a negative under the radical. So these are the 3 cases. Sometimes we end up with a nice positive number under the radical. That's when we're going to end up with 2 solutions. Sometimes we end up with 0 under the radical. That's when we're going to end up with 1 solution. And sometimes we end up in that weird case where there's a negative under the radical. And when I take the square root of a negative, that's when I enter the imaginary world. So if it doesn't cross the x-axis or if I have the square root of a negative, that's when there's no real solutions. Having said that, that's the real world. We do have 2 non-real solutions. Okay, so with the i's in it. All right, now let's take some notes on that. Okay, the discriminant. If I ask you to find the discriminant, I am only asking for the b squared minus 4ac. Okay, it's the value of the part under the radical. Just so you know, there is a special name for the part under the radical. It's called the radicand. You don't really need to know that for this, but it is just good to know. Okay, so it's that part under the radical, just the b squared minus 4ac. And what we just saw is that if that part, if the b squared minus 4ac is positive or greater than 0, that's when we will have two real solutions. Sometimes we call them roots instead of solutions. Oops. Solutions or roots. Or they could be called x-intercepts. That's where it crosses the x-axis. If, however, when you do that b squared minus 4ac, you get 0, so if it's equal to 0, that's when we have one real solution. Or one real root. And finally, if you get a negative under the radical, so if b squared minus 4ac is less than 0, then we have two non-real solutions. Or as we've learned about, that's the imaginary world. So they will have an I in them. Okay? So sometimes when I've taught this in the past, we've actually taught the discriminant first. So we just teach the b squared minus 4ac. And before we even use the whole quadratic formula, we decide how many solutions we're going to have. You saw yesterday that when I did the quadratic formula, I actually do this as side work anyways. So the order doesn't really matter, but sometimes it's nice to know on the front end how many solutions you're going to have before you actually find what they are. And that's what today's lesson is. So in these cases, we're not actually going to find the answers. We're just going to describe the types of solutions. So really we're saying two real solutions, one real solution, or two non-real solutions. So as soon as I'm asked to do that, I just need to do the b squared minus 4ac. I once again figure out my a is 16, my b is 8, my c is 1. Substitute, I get 8 squared minus 4 times a is 16 times c is 1. Again, I do recommend just typing that all into a calculator with the parentheses. Otherwise, if I do it one step at a time, 8 squared is 64. Of these three pieces, there's only one negative, which means it's minus, and 4 times 16 is actually 64 as well. So I would just get 0. Now again, all we're looking for today is because my discriminant is 0, the answer is that there will be one real solution. Go ahead and pause the video quickly and try number 2 on your own. Hopefully you identified that a is 2, b is negative 5, c was 6. When you plug that into b squared minus 4ac, you should add negative 5 squared minus 4 times 2 times 6. Which gives me positive 25. One negative means minus 48. So I get negative 23. So because the discriminant is negative, this is where I would end up with two non-real solutions. Okay, so that's the skill work part of the lesson today. Now let's look at how we could apply this in the real world. Here we see that Rachel's about to serve and tosses a tennis ball straight up in the air. The height h of the ball in meters at time t in seconds is given by h of t equals negative 5t squared plus 5t plus 2. All we want to know is, will the ball reach a height of 4 meters? It's not even asking when that will happen. It's just saying, will it happen? Well, if we want to know a height of 4 meters, that's the output here. So they're basically saying, when does 4 equal negative 5t squared plus 5t plus 2? And again, not when does it, but will it? In order for me to figure this out, I first always need to get a quadratic equal to 0 before I can do any other work. So I would subtract the 4 from both sides. So I get 0 equals negative 5t squared plus 5t minus 2. Again, if it said, when will it reach 4 meters, I would just start solving, probably using the quadratic formula. Having said that, if it just wants to know will the ball reach that, I just need to see if there are any real solutions, because if there are, then yes, it will reach that height. To figure out if there's real solutions, I only need to find the discriminant. So my A is -5, my B is +5, my C is -2. Plug in 5 for B, -4 times -5 times -2. 25, I have a negative, and a negative. 3 negatives multiplied together gives me a negative. And when I do 4 times 5 times 2, I get 40. Oh dear, what happened there? 25 minus 40 is -15. Again, I haven't found any answers, but when I get a negative discriminant, that means there are 2 non-real solutions, which means that it actually doesn't happen in the real world. There aren't any real solutions. So since there are no real solutions, the ball will never reach 4 meters. Okay, so if the wording is this way, where it's just asking, will it reach a height, you would just check to see if there's any real solutions. Okay, and the next problem, you're going to try this on your own. We're going to keep using the same example. So we're going to use the same function, but we're going to change what height we're checking. So here's what you're going to try. According to Rachel's model, according to the model of Rachel's serve, will the ball reach a height of 3 meters? Okay, so again, here's the function that you're starting from, -5t squared plus 5t plus 2. But instead of 4, you're checking it for 3. So pause the video, plug in 3 instead of 4, and find the discriminant to see if it will ever reach the height of 3. Again, hopefully you took it and set the function equal to 3 this time, which changes your C value. So I'm going to subtract 3. I get 0 equals -5t squared plus 5t, and this time -1. So my A is -5 still, my B is still 5, but my C in this case is -1. So if I find the discriminant with those values, I get 5 squared minus 4 times -5 times C, -1. 25, once again, 3 negatives still gives me a negative, but this time I just have 4 times 5 times 1, which is 20, which means the discriminant is 5. And in this case, this means there's 2 real solutions, which means the answer to the question is yes, the ball will reach 3 meters. Because 5 is greater than 0. And so there are 2 real solutions. Okay? And so it would actually hit that 3 meter mark twice. Obviously, it would be once on its way up and once on its way down. So that's how we can use this idea of the discriminant, not to determine exactly what time it reached the height, but just the fact that it does reach that height. Okay, last but not least, I just want to show you one other twist with discriminant. If I want to know what value of B will cause this to have one real solution, okay, so I'm given a quadratic where they show me A is 2, B is unknown, and C is 18. We can use what we know about discriminants to be able to solve for B. Because if I need to have one real solution, that's when the discriminant b squared minus 4ac is equal to 0. If I wanted to know when there was no real solutions, I'd put a less than here. If I wanted to know when it had 2 real solutions, I'd put a greater than. It's easiest to solve when it's in equals though. One real solution isn't too bad to solve for B. So now I substitute what I know. I don't know B, so I keep it as b squared minus 4 times a is 2 times c is 18, and that needs to equal 0. And now I just solve. B squared, again I have a negative times a positive times a positive. One negative means it's minus. 4 times 2 times 18 gives me 144. And now I solve for B. Add 144 to both sides. B squared equals 144. To solve for a square, I square root it, and as we've learned before, that means that the two different options that would give me 144 are 12 times 12 would be 144, but also negative 12 times negative 12. So my two answers are that B could be positive 12 or negative 12. All right, just a quick summary of 2-6. The biggest thing is we want to make sure we know what the quadratic formula is and how to use it. And then we also want to understand this idea of the discriminant. The discriminant is b squared minus 4ac, and that helps me determine if there are two real solutions, and that's when it's greater than 0, one real solution, that's when it's equal to 0, and two non-real solutions. So when you get those imaginary numbers, that's when the discriminant is less than 0. Go ahead now and start working on your 2-6 day 2 Pearson practice.